So this next question, question 2, it's a data analysis question, evaluation analysis question. So you have various masses of solid barium hydroxide, and you have hydrochloric acid, and you contain a polystyrene cup. So this is about calorimetry. So you must have done this kind of experiment before. This is about a strong base and a strong acid. So this is most likely about enthalpy of neutralization, which is part of your AS syllabus under enthalpy changes. So in each experiment, you have a fresh sample of the acid, and you measure initial temperature as you would normally do in a calorimetry experiment. After you add the barium hydroxide, you stir the acid because you want to ensure a uniform mixture of the acid and the base, and then you reach a maximum temperature. So this reaction is exothermic, as you would know from neutralization. It's just H plus OH minus give you H2O. So involve the recombination of the H plus and OH minus to form the new covalent bond, which is OH covalent bond, without breaking anything because they just come together. Oppositely charged ions by electrostatic, they form the covalent bond, and therefore it's exothermic, and that's why you get a maximum temperature reach, because enthalpy of neutralization is exothermic, never endothermic. Alright, so results of the experiment are recorded in the table below. You need to complete the table to give the temperature rise. So temperature rise is actually delta T, not T. Alright, barium hydroxide added in mole. Okay, so you're not given any periodic table in paper 5, which is why they already given you all the information here. So this is telling you the MR of barium hydroxide. So the mass of 1 mole of the substance is, well, the molar mass, gram per mole. That's what they're saying. The mass of 1 mole of that is gram per mole. So what do we need? We need the amount to 3 significant figure, but we need the temperature rise to 1 decimal place. So this kind of thing are very important not to lose marks on, and it's only 2 marks. And I've gotten my calculator. Well, I've dig out my old calculator back again, having lost my newer calculator recently. But anyway, still know all my old calculator. So the initial temperature is there's the maximum temperature reached. So 22.2 minus 21.0. Get 1.2. 2.4. So this kind of thing takes time, yeah. And do not think that it's just a matter of keying a calculator and stuff. I would highly encourage you to actually time yourself and see how long you take doing all this without making any mistake at all. And this includes the next bit, which is plotting of graph, because it takes practice actually. And if you don't believe me, you should, if you've never done a paper 5 before, you should try and see how long it takes you, because why are they the same? Have I done something wrong? Nope, they're the same. What I'm saying is that the same skill set is also essential for your so the next bit, which is the mole, is just the mass over the MR. As I was saying, the next bit, drawing graph, is also essential in all your other sciences as well, depending on which sciences you take. Yeah, paper 5, alright? I'm sure they involve drawing graph as well, yeah? 585, so this is the one that I had to convert because it's as 0.005847, so 3 sig figure. 1.50 divided by 171 0. .0117. This is another one I had to run it up correctly. Okay, so there's the last bit of it, and now, unsurprisingly, they want you to plot a graph to show how the temperature varies with the mole of barium hydroxide. So unlike the usual calorimetry kind of diagram where it's temperature against time, this is different because it's temperature rise, which is this table here. So this is the y-axis, because y-axis against the x-axis. So this is the dependent variable. So if you watch my other 5 tutorial video, you would know that I credit this friend who taught me this very catchy phrase that why are you so dependent? Why are you so dependent? So the y-axis is the dependent variable. Okay, it's the one you measure as you change the independent variable. Okay, as you vary the independent variable. So they already given you the graph kind of plotted out with the points and the labels, and that's why the marks are not a lot. I'm not entirely sure how it works in physics, but I know in the older paper 5 papers for chemistry, it used to be like 4 or 5 marks where they just give you empty graph and you need to come up with everything from scratch. Okay, so that took a lot more time, but even despite this, it still takes time, so I highly encourage you to actually practice doing it. Okay, so I have my value on another piece of paper because I can't bother flipping back and forth. Well, let's get started then. So 0.00292, 0.00292. So first thing with this kind of graph is you need to think about what each of these actually means. So this is 0.005. So each of these is 0.001, 0.002, 0.003, 0.004. So what I'm looking at is 0.00292, so that's close to 0.003. 0.003 is 1.2. 0.003 is 1.2, so it's roughly there. Maybe I draw it a bit better. 0.003 and 1.2. And then 0.00585, give or take, is 0.006. So 0.006 and 2.4. 0.006 and 2.4. And then 0.009, which is 0.00877, rounded up, because it's almost impossible to get that at precision on this graph itself. Yeah, it's easier to look for 0.009 and 3.7. 0.009 and 3.7. So now you 0.012 and 4.7. 0.012, 1112, and 4.7. Is that right? Yeah, 4.7. And then 0.0175. So this one is an exact value because this is 0.015. So 0.016, 0.017, this is 0.0175, exactly in the middle. So 0.0175 is 7.3, 7.3, so 7.1, 2, and 3. And then 234, I would imagine that would be close to 235. So 234 and 9.7. 234, so there's 1, 2, 3, so there's 0.023. You gotta realize that this is 0.024. Oop, there. So this is 0.0235, so somewhere in between there. 0.0235 and 9.7. 0.0235 and 9.7. 9.7 is there. And then 0.0351. So 351 will be close to 0.035, I would imagine. And that's 10.4. 10.4. 10.4, 10.4, 10.4. Am I correct? 10.4. Yep, okay. And then 0.0468 is close to 0.047. So that is 0.045. So 46 and 47, 47, 045, 045, 046, 047, somewhere there. Give or take 10.4. All right, cool. So I've gotten what I needed. It seems that if I zoom this out a little bit smaller, it seems that well, obviously when you have no barium hydroxide, then you would not expect any temperature rise at all. So I know this graph will cut through 0, 0 because when there is no barium hydroxide added, there is no neutralization. Therefore, the temperature is just the temperature of the acid, right? Because you dip the thermometer inside the solution containing the acid, then you add the barium hydroxide. So it's got to cut through 0, 0. I can see, oops, sorry, that's too small. I can see that it's going to look like that. And then there's a constant line like this because the temperature flatten out because it has a maximum temperature rise, then it doesn't go any further. So I need to try and draw a straight line first of all. So I can do this on my screen fairly easily because, well, you know, that's the beauty of working on the screen. So you see, you want the best fit straight line, but that doesn't matches all the points on top. So I think that is the closest I can get to as many points as possible. Not really, because you see this thing here, I think I've done a mistake. It doesn't cut through 0, 0 now, so that's no good. I'll start again. So let me start. That's no good either. This is actually harder than I thought it would be. It's actually a lot easier if you have a ruler, then you can play around with it. Okay, so I think that is the best I could do. And then what I will do later on now is to join a horizontal line. Is that the best I could do? I could do better. So we know that it cut through 10.4, right? So if I just kind of draw this straight line first, and that's probably as straight as I could get it to be on my screen. So that's where they cut through, because this is a constant point. And yeah, I think that's it really. So it's draw two lines of best fit on your graph. Rather than trying to draw a curve, it's actually draw two lines of best fit. State the value on the x-axis, so you need the thing on the x-axis at the point of intersection. So not the y-axis, but the x-axis. So what was that? There's somewhere there, and it's the, I would say it's roughly the first square of that thing there. So it's here, and then the first square there. So we're looking at that. 0.021, 0.022, 0.023, 24, 25, 0.0255. So 0.0255 is the value on the x-axis at the point of intersection there. Okay. So use the value on the x-axis at the point of intersection. Calculate the concentration of the hydrochloric acid in mole per dm cube. So to do this question, you really need to think about the equation, the balance equation. So the HCl, so you need two of it because barium hydroxide has 2 OH minus, and that will give you BaCl2 plus H2O, and you should get 2H2O. All right, so the ratio of HCl is to the mole ratio of barium hydroxide. You will have known that I like to use fractions like this after I stated them out very clearly like this, because it's just my way of bookkeeping, and I've always maintained this method throughout my calculations involving mole ratios from paper 1 to paper 2, 3, 4, and 5, and this is the usual way that I usually teach students. Because for me, when I write them out clearly like this and set them up like this, there's almost no way it can go wrong, okay? Unless you don't know what you're talking about. Balance equation, 2 mole of HCl reacts with 1 mole of barium hydroxide. And how much volume of HCl do we use? Well, there is 60 cm cube of hydrochloric acid. So there was 60 cm cube of HCl. 60.0 cm cube HCl, and we want the concentration of the HCl, so all we want is the concentration of the HCl. So if I set it up, the square bracket refers to the concentration of the HCl. This is in mole per dm cube times the volume, change it to dm cube, divide by 1000. And then at the bottom, the mole of the barium hydroxide used was the x-axis, the mole of barium hydroxide added from the point of intersection, 0.0255. Oops, nope, I don't want that. I don't want that. Nope, nope. Okay, 0.0255. So that is all set up nicely. The concentration of HCl will be 2 times 0.0255 divided by 60.0 times 10 to the minus 3. So put it into your calculator. And I get 0.85. That is what my calculator show me. But I guess to be consistent with what I've written down from there, as well as the volume of HCl used, which I think was 3 significant figure, 1 to 3 significant figure, and my intersection point was 3 significant figure as well. So what I'll do is, instead of leaving it to 2 significant figure as my calculator show me, I will write it to 3 significant figure, because this is what we call appropriate number of significant figure as required back in your chapter 1 syllabus from the Cambridge curriculum. Okay, so next bit, explain the variation in temperature. So you need to explain it when you add barium hydroxide to the hydrochloric acid. So the graph has 2 parts of it. Okay, so there's the first part, and there's the second part when the temperature rise become constant, where there's no further change in temperature. The fact that we get a temperature rise, as I mentioned earlier, is because this is a neutralization reaction. So the neutralization reaction is just H plus OH minus, so it's just the recombination of oppositely charged ions, and you are not breaking any bond. In fact, you are forming hydrogen and oxygen covalent bond. So enthalpy of neutralization is always exothermic, okay, never ever endothermic. When you think about the ionic equation, they represent any neutralization equation, right? So initially, so meaning at the very beginning, as we add more barium hydroxide. So when you add more and more barium hydroxide, the temperature rise, which is the y-axis on the graph that we just drew. Temperature rise or temperature increase. Temperature rise. Temperature rise is the value. Okay, so that is the noun itself. The temperature rise increases in value. Increases in value much increases in value as there are more OH minus that neutralizes the H plus. So obviously the more water you form, the more H2O molecule you form, the more heat energy that the reaction will release. All right. So after all, so because you have a fixed amount of hydrochloric acid, okay, you have a fixed volume of hydrochloric acid of a specific concentration. So after all the H plus have been consumed or neutralized in the technical term, that means no more H plus. So any extra or you call them excess barium hydroxide added will have no effect, will have no further effect on temperature. And the reason for that is because there's no more H plus to form H2O with the OH minus, so the OH minus just remain as it is. All right, so no more water being produced, no more H2O is produced. If you don't produce any more H2O, therefore no further change in temperature, meaning no further temperature rise. Okay, no further change in temperature, therefore temperature rise become constant. Okay, Next bit of the question, when the experiment is done in the way described, the results are not very accurate. So this is to do with accuracy. Apart from the limitations due to accuracy of the measuring equipment, so you can't talk about using a better equipment that can have lesser number of error, because there's already said apart from that, okay, other than that, except for that, suggests. So a lot of these are higher order thinking questions, so you need to be ready to think through your practical experiments. Yeah, all the temperature rises are less than the theoretically should be expected. So this reaction releases heat, but what you actually measured is actually lesser. It's not as high as it doesn't go to as high as what it should be on paper theoretically. Okay, and because this reaction release heat, I can be thinking about heat loss. All right, so that means if my reaction loses heat to the surrounding, not all the energy goes into heating up the solution which contain water. So obviously we don't measure, we don't see on the thermometer as high as possible on the thermometer reading, because some of the energy is being lost to the surrounding. So you can think about heat loss to the surrounding. So your surrounding consists of air as well, like gases in the air. They can get warmer as a result of the energy being transferred to them, okay, such as your air or your gases. All right, so i.e. not, as I mentioned just now, not all the heat released by the reaction goes on to heat the water or the solution. So your acid consists of water. They are dissolved in water, right? The same goes for the base, is dissolved in water as well, obviously. Yeah, and of course once your barium hydroxide dissolved in the water, it's soluble. Okay, so why the temperature rises are more inaccurate as they approach their maximum value. So as you go higher and higher, so the reason why you approach a maximum value is because there's no more temperature rise, right? And that's because the reaction is nearing completion. So that means the H plus is slowly being used up already. So the reaction will be slower. The reaction is slower as it approaches the maximum temperature rise value, because that means it's working as much as it could already, and maximum temperature rise value. So what we could say is that because the reaction is slower than, so the heat loss is a lot greater. Heat loss is nearing the maximum at that stage. Okay, as a result of that, so your value on the y-axis, which is the temperature rise, become more and more inaccurate as it approaches that maximum value. All right, so as a common thing when you have calorimetry kind of experiments which releases heat energy or which absorb heat energy, you want to minimize this energy exchange with the surrounding air. Okay, because gases can get warm up, gases can be cooled down, and you want to minimize that. So one of the improvement that is very common is you just use a lid. You use a lid to cover the polystyrene, or what we call the styrofoam cup. Okay, I think they call it polystyrene cup, but you might have heard of styrofoam cup when you did your practical experiments. Okay, there's one thing you could do. Another thing you could be thinking about is that I think the barium hydroxide was supposed to be added. You see, the barium hydroxide is added as a mass, because added as a solid, sorry. So it's a solid there. So in order for the temperature rise to be as accurate as possible, you want the reaction to take place fairly rapidly, okay? Because if you have a huge chunk of a solid, it's going to take a while for the acid to get into the inner part of the chunks, solid chunks that contain the barium hydroxide. So it's better if we crush up the solid barium hydroxide to make it into a fine powder so that we get a faster or rapid initial rate, and this will give us a more accurate maximum temperature rise. Okay, so you can say or crush the solid barium hydroxide use to maximize surface area. So as you know, surface area can affect rate of reaction. So maximize surface area for rapid or fast initial rate of reaction. And when you have fast enough, and you can get a much more accurate representation of the temperature rise, right? So this is the last bit of this data analysis question, and it's worth 3 marks, so quite a lot of marks. This is about, instead of using hydrochloric acid, you use ethanoic acid. So ethanoic acid is a weak acid, hydrochloric acid is a strong acid. So this is back to your GCSE or IGCSE or O-level understanding of acid versus bases. And we're talking about that they have the same concentration, so we use the same concentration, but you want to draw on your graph another pair of line. So you need to have 2 best fit straight lines again, what you would expect to obtain, all right? And you gotta explain the answer. So before we go about it, let's think about the weak acid versus the strong acid. So the weak acid, this also give you only 1 H plus per molecule, just like HCl only give you 1 H plus per molecule. All right. Obviously, like, because they have the same concentration, and this give you 1 H plus and this give you 1 H plus, the equation that you could write, I guess, CH3CO2H plus barium hydroxide. So as I mentioned, you have 2 hydroxide, you need 2 of the ethanoic acid, because each of these only give you 1 H plus. Since you have 2 OH minus, you need 2 H plus in order to balance out the formula, just like that. So it's not different from what we have shown with 2 HCl and giving you BaCl2 and 2 H2O. Okay, so the mole ratio is exactly the same, and therefore since the mole ratio is the same, and also we have the same concentration of ethanoic acid on paper, based on the equation, all right, based on the equation, so the mole of acid reacted, actually the mole of ethanoic acid reacted, is equal to the mole of HCl reacted in the previous equations. Therefore, no change in the mole of barium hydroxide required for neutralization. Okay, required for neutralization. So meaning to say, the intersection point, at the intersection point, the x-axis value will not change. Okay, so no change in the x-axis value where the new lines intersect. So definitely we have new lines because this relates to the second part. So that was the x-axis doesn't change, but then the y-axis to do with temperature rise, and because we have a weak acid, so a weak acid like ethanoic acid only partially dissociates, or we call them dissociates into, well, dissociates or ionizes. Actually the other word is ionizes. You should choose one, but know that both of them have the same meaning. Okay, ionizes into H plus in solution, whereas a strong acid dissociate completely into H plus in solutions. So therefore, not as much H plus compared to same concentration of HCl, same concentration of strong acid HCl in solution. And as a result of this, if you don't have that much H plus, then you are not producing as much H2O molecule as a result of neutralization. So therefore, not as much H2O was produced or is produced, I guess. I don't know about the past tense or the present tense. Anyway, that's not the most important thing. So I should probably write that better. Was formed or produced, I guess produced or formed due to neutralization. If that is true, then it will release less heat. Therefore, reaction here will release slightly less heat. So it is still exothermic because you are still reacting H plus with OH minus, but you will be releasing less heat. Therefore, slightly lower temperature rise. So your y-axis where they intersect will be lower. Okay. So going back to the graph, here you have something that goes higher like this, and that's the intersection point where the pink value is. What I expect is that it will be low. It will still be 0, 0 because when I don't add any barium hydroxide to ethanoic acid, there can be no neutralization, and therefore there can be no temperature change. But it will be lower, but it will still get neutralized at the same amount of barium hydroxide added because of the equation I just mentioned earlier. All right. So if I use a slightly, I already have blue there. This is a sketch, right? So I'll just sketch something out. I guess make my life easy and so that you can easily see what is going on. If I just have any good old straight line like that, and then I can start from 0, 0. Doesn't matter because this is a sketch. So important thing, start from 0, 0 because when there is no base being added to the weak acid or strong acid, there is no neutralization, therefore no temperature rise. It's a weak acid, there is lesser H plus that it dissociates into in solution, and therefore lesser H plus mean lesser neutralization, extent of neutralization because you have lesser H plus in solution, and therefore you don't produce as high of a temperature rise. In fact, I have made a mistake. It shouldn't be that. Remember that on our x-axis, it has to cut through there. All right, so I guess that is better, and I guess I can extend this a little bit. Okay, so that looks better. So important thing is that they both intersect at the same point because they are both ethanoic acid and HCl are what we call monobasic acid because each of them only give you 1 H plus per molecule. All right, so they cut through at the same x-axis value, but the y-axis value will be lower. Okay, as a result of what I just explained. So that marks the end of this paper 5 tutorial.